Hello everyone, welcome to MAP 2020. I am Zishan, Senior Team Lead at MathWorks. Today Kranti and I will talk about OFDM transmitter and receiver HDL reference application. In 20B, under Wireless HDL Toolbox, you can find OFDM reference applications. I will talk about HDL OFDM MATLAB reference, and Kranti will talk about HDL OFDM transmitter and receiver Simulink models. So let's get started with HDL OFDM MATLAB reference. This reference application is first step towards FPGA prototyping. We all start with MATLAB because it's easy to follow and easy to make modifications. You can do quick algorithmic exploration in MATLAB, and once you are done with the exploration, you can model hardware architectures in Simulink. You can then verify your Simulink models with MATLAB code as a reference. There are different tunable parameters present in this reference application, such as modulation order, code rate, number of frames, and transmit data bits. You can then pass these parameters to OFDM-TX MATLAB function. OFDM-TX MATLAB function forms OFDM resource grid with synchronization signal, reference signal, header and data signals. OFDM resource grid is then passed to OFDM modulator followed by TX filter. The function returns time domain TX waveform, frequency domain grid, and TX diagnostics. TX diagnostics can be used to debug or verify Simulink OFDM TX models. Noise is added to the transmitted signal to simulate an AWGN channel and then passed to OFDM-RX MATLAB function. OFDM-RX MATLAB function performs time and frequency synchronization, OFDM demodulation, channel estimation and equalization, followed by header and data recovery. The function returns RX data bits and RX diagnostics. RX diagnostics can be used to debug or verify Simulink OFDM RX model. My colleague Kranti will now talk about these Simulink models. Thank you.
Hello everyone, my name is Kranti. I am a principal engineer at MathWorks. I will now talk about Simulink OFDM reference application, which is one of our hardware-proven subsystems in Wireless HDL Toolbox. Simulink is best suited for hardware modeling because it can model timing and showcase the hardware architecture. The MATLAB data is passed from workspace blocks to configure the HDL OFDM transmitter. User can give the transmitter input data from the lookup table. Looking inside, the frame controller subsystem restarts the frames repeatedly. The frame generator subsystem consists of different subsystems that generates training and data signals, which are later OFDM modulated, then filtering. The received input data obtained from MATLAB workspace blocks. Input impairment control bus controls all the impairments and its parameters externally. The synchronization subsystem performs frequency and time synchronization and OFDM demodulation, which is hardware ready IP block. The demodulator output is passed through channel estimation and equalization followed by common phase error estimation and correction. The decoded parameters from the header recovery are used to decode the data in the data recovery subsystem. It consists of symbol demodulation, depuncher and Viterbi decoder, which are hardware ready IP blocks you can plug in and configure. All these results from the diagnostics are written to the MATLAB for analysis and comparison. Here we verified and compared each tap point data of the Simulink OFDM transmitter and receiver with MATLAB. At this point, we can generate the HDL code and run FPGA synthesis. Make sure you have a right subsystem. For now, we can consider receiver subsystem. You can run the FPGA synthesis using Workflow Advisor. Workflow Advisor guides you through the full workflow. It takes little while to run synthesis and implementation. The resources and timing results for the Zynq 706 target device with 150 MHz target frequency are here. This hardware subsystem is set up with a model reference, so you can either use as is or make your own modifications as per the requirement. For more information, please go to Wireless HDL Toolbox.